Okay, in this video I just want to practice calculating some logarithms. So in the previous video we talked a little about what exactly the formula is going to be. Let me go ahead and write that down again so we don't forget. Log base b of a number x is supposed to be y if b to the y is equal to x. So again, the number down low is the base, the number inside the parentheses is the answer, and then we're looking for what's the exponent. Okay, so let's try this out. And honestly, most of the time I'm probably just going to write it as an exponential. This is called the exponential form of the equation. Just so I can see, like, my brain is programmed to work well with exponents. So let me write this logarithm in terms of exponents, and then it shouldn't be that scary. So the base is 2, the answer is 32. Okay, so the mystery number must be the exponent. And then we just have to check powers of 2. If 32 is a power of 2, I just have to figure out which power it is. 2 to the first, 2 to the second, 2 to the third. This is 2, and 4, and 8, and 16. I found it. Okay, so the 32 is a power of 2, specifically it's 2 to the 5th. So the missing exponent is 5. And so again, if this y is 5, that means log base 2 of 32. The answer is 5. Okay, so keep in mind that, let me, I guess, erase the question mark now and put the number 5. Now we know it's 5. Keep in mind that a logarithm equation can be rewritten as an exponential equation because the two are inverse functions of each other. We just got to swap inputs and outputs. So whenever I see a logarithm that I'm trying to compute, I want to look at the corresponding exponent, and I should be able to just see, okay, yeah, that looks okay. Okay, let's try the next one, log base 3 of 1/9. So the base is 3. I don't know the exponent, so the exponent is going to be my question mark, and the answer is 1/9. And so I have to be a little creative. How do I make a power of 3 turn into 1/9? I know that 3 squared would be a 9, but how do I make it into a 1/9? And keep in mind that fraction exponents give you roots, and negative exponents give you reciprocals or fractions. And so if we want our answer to be a fraction, that means that we're looking at a negative exponent. So again, 3 squared would be 9. If I put a 3 to the negative 2 power, I think that would move the 3 squared into the denominator. And so apparently the missing exponent in this logarithm, or in the corresponding exponential equation, is negative 2. Okay, let's try another one. The base is 7. The answer is 1. So 7 to a mystery power is supposed to be equal to 1. And this is one that we should have somewhere deep, deep, deep in the vaults of our memory. Because any number to the 0 power spits out 1. So it doesn't even matter that the base is 7. Anything to the 0 spits out 1. And so if a power of 7 is equal to 1, the power must be a 0. I'm using this rule right here. And so I guess if that's the missing exponent, that should be the answer. So again, looking at over here, the base b is 7. The inside of the logarithm is 1, so that's the answer to the exponential. And then the inside of the exponent is the 0, which should be the answer for the logarithm. So again, keep in mind that the input of a function is the output of its inverse. The output of a function is the input of its inverse. They swap x's and y's. That's another way to think about it. If this whole find the missing exponent isn't making sense to you, you can also think about them as being inverse functions. Okay, I have to be really careful here because I was expecting the 5 to be the base, but it seems like 25 is the base. And the number that's down low is the base. And so this is saying base is 25. We're trying to find the exponent, and the answer is 5. Okay. And I actually already wrote down the answer here. The square root of 25 would spit out a 5. So the square root of 25 would be 5. And so why don't I write the square root of 25 as an exponent? A square root or a 2 root would be a 1/2 power. And so apparently the missing exponent is going to be a 1/2. So looking at this, we have our answer right below it. 25 to the 1/2 power spits out a 5. Okay, I'm going to need to write something. I'm going to need to erase something so I have room to work on this last problem. Okay, this last problem, the base is 2 and the answer is -8. So 2 to the power is equal to -8. Okay, you can go ahead and try guess and check if you want, but there's not going to be a good way to do it. 2 cubed would be +8. 2 to the -3 would be negative exponent takes a reciprocal, so not -8. Find random things that might spit on the negative. I can't think of a number I could put in the exponent to spit out -8. And it turns out there isn't one. If I look at this, if 2 to the x is equal to 8, -8, think about the function 2 to the x. If I'm comparing 2 to the x to -8, when does 2 to the x hit the graph of y equals -8? Never. This has a horizontal asymptote. It never gets negative. So if this function never gets low enough to hit -8, then I'm never going to be able to come up with an x to make this work. So I guess I'm just going to write does not exist. Okay, so it turns out we can't take logarithms of negatives. Who knew? Okay, so I'm going to save that for a later discussion. That will probably make more sense when we start to talk about the graph of a logarithm. So let's hold off for now, but just start thinking now that there are some issues with the domain of logarithm. We're going to have to talk about what numbers can we and can't we plug into a logarithm. Up until this point, the only times you're really worried about domain is make sure you're not dividing by 0, make sure you're not taking a square root of negative. Now apparently there's a new kid on the block and he's going to cause his own set of problems. We also need to make sure we're not taking logs of negatives apparently. Okay.